Now, let's move on to the other part of the chapter. Can matter change state? We know that matter exists in three forms of state, right? Solid, liquid, and gas. But are these interchangeable? Let's find out how matter can change its state. As we know, water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. Hence, matter can change its state by applying factors like temperature and pressure. Now, this is a very easy thing that you must have noticed, that ice exists in the shape of solid, liquid is the water, and gas is the water vapor, right? But there is a continuous change happening, a continuous phase of transition happening between one state of matter to another. And the most easiest way to explain this is to take the example of water, because water exists in all the three states, and the interconvertibility of all the three states of water is also easier as compared to any other state of matter. So the process where solid changes to liquid, so that is the process where ice changes to liquid water, is fusion. The process where liquid water it freezes into ice is known as solidification. Okay, the process through which liquid changes into the gaseous state, so the process through which you may say water changes into water vapor is vaporization. But the process through which gas changes to liquid is the condensation. The process through which water vapor changes into water is condensation. Now there is a very unique thing which also happens. The state of matter, the solid state, it can also convert into a gaseous state without without reaching the liquid state. This happens in a few of the substances. We will see that later. So solid changes into gaseous state with the process called sublimation, and the process when gas changes into liquid, this process is called deposition. What is the effect of change of temperature on solid? On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving freely. A stage is reached when the solid melts and is converted into a liquid. What is happening here? If you may remember the earlier incense stick experiment, or the earlier thing where we determined that hot food, the smell of hot food can reach you faster than the smell of cold food. What was happening there was you had lit the incense stick, you had increased the temperature, and you had warmed the cold food. So you had increased the temperature. So we have already determined that as you increase the temperature, the kinetic energy of the particles they increase. That is why they were easily able to diffuse, they were easily able to intermix with the particles of air, and they were easily able to flow and reach towards you. Similarly, here we are seeing that on increasing the temperature of solids, the kinetic energy of the particles increases. And due to the increase in kinetic energy, particles start vibrating. Okay? And the energy supplied by heat overcomes the forces of attraction between the particles. So what is happening is that when you take a piece of ice and when you heat it, so a particular temperature, the ice will heat, and a particular temperature will be reached. From that temperature, what you will notice is that the particles start vibrating, and there is a change in the state of matter. So the solid will be diffusing, the process that we had seen earlier. The solid will be fusing into liquid, alright, and you will be noticing that the ice is transforming into liquid. On heating the liquid again on a particular temperature, you will notice that the liquid of water, it is now turning into gaseous state. So when applied a certain amount of temperature, after that fixed certain amount of temperature, you must be noticing that the states of matter, they are changing from solid ice to liquid water and then to gaseous water vapor. What is melting point? Now, like I told you earlier, that when you were heating that piece of ice, you heated, and then a particular temperature was reached. When that ice was melted all into water. So the minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. So the minimum temperature, so you are supplying heat to the solid, but the minimum temperature at which that piece of solid, it transitions into the liquid state, that minimum temperature at the atmospheric pressure is the melting point. Melting point of a solid is an indication of the strength of the force of attraction between its particles. That means when you apply heat, so the kinetic energy is increasing, and because of the increase in the kinetic energy, what is happening, that the tightly wounded particles of solid, the high intermolecular forces that they had, when a high amount of energy was applied to them at an increase of temperature, so what happened is that owing to the high kinetic energy, the intermolecular force, it decreased and the intermolecular space increased, and that is how a solid is transitioning into a liquid. What is fusion? So in that crisscross diagram, you have noticed that when a piece of solid is changing, is transitioning into liquid, this process is known as fusion. The process of melting. We also very in layman terms we say melting. So the process of melting, that is change of solid state into liquid state. This process of melting is known as fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? This heat gets used up in changing this state by overcoming the forces of attraction between the particles. So what is happening, like in the earlier drawing that I told you, that the particles of solid, they have high intermolecular force. So when heat is applied, when the temperature is increased, they gain more kinetic energy, right? But an interesting thing is to notice is that when a solid melts, its temperatures remains the same. So at a particular melting point as in the particular temperature, minimum temperature at which a solid melts all into liquid, the temperature remains the same. So we'll be learning further that the melting point of water is 0 degrees Celsius. So the transitioning phase from ice to water is 0 degrees. So what is happening here is that when the temperature remains the same, but during the temperature, all the solid is transforming into liquid. So as this heat energy is absorbed by ice without showing any rises temperature, it is generally considered that it gets hidden into the contents of the beaker and is known as the latent heat. So what is happening is that it gets hidden in the content of the container. It means that it is used up, that since the temperature is not increasing, but you are applying the source of heat, right? So all that heat energy is being absorbed by the particles of solid to change their state. And how do they use it? They consume that energy by lessening that intermolecular force of attraction, so that the space is increased, the attraction is decreased, and they are able to transition from solid to liquid. And because this heat, that extra heat that has been provided, because there is no rise in the temperature, but you know that you're providing heat, right? So this is known as latent heat. Latent means hidden. So there is no obvious increase in temperature, but there is a supply of heat. So this heat is getting absorbed, it's getting hidden between the particles of solid, and therefore it is known as latent heat. What is latent heat of fusion? The amount of heat energy that is required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. What is happening here is that the amount of heat, so you have to remember always 1 kilogram. There is a certain standard through which we measure everything, right? So the amount of heat that is required to change 1 kilogram. 1 kilogram is the standard measurement. So amount of heat required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is latent heat of fusion. So particles in water at 0 degrees Celsius or 273 Kelvin have more energy as compared to particles in ice at the same temperature. How is that? because when the ice is changing into water, and you know that the melting point of ice is 0 degrees Celsius, so when that is happening, because there is no significant increase of temperature but the heat is being absorbed, so heat is being absorbed, that means a certain amount of energy is also being attributed towards the particle. And since the particles are transitioning, since they are in a transitioning phase, that is why particles in water at 0 degrees Celsius, they have more energy as compared to particles of ice at the same temperature. What is boiling point? The temperature at which a liquid starts boiling at the atmospheric pressure is known as the boiling point. So the boiling point of water to its water vapor, it's 100 degrees Celsius. So at 100 degrees Celsius, what will happen is all the liquid state of water will be transitioning into the gaseous state of water vapor. Boiling is a bulk phenomenon. That is, particles from the bulk of the liquid gain enough energy to change into vapor. How is that? Because water, it comes on the surface, right? So if suppose this is a beaker, okay, and you are supplying heat to this beaker, right? So water, all the particles that are there at the surface of the water, they are consuming heat, and when a particular temperature of 100 degrees Celsius is reached, there will be no increase in the temperature. But since these particles have absorbed heat, okay, so in a bulk they will be transitioning, in a bulk, as you know, the particles are there at the surface, so in a bulk they will be transitioning into the gaseous vapor state, as also seen in this diagram. Question: what do you understand by the latent heat of vaporization? So it's a very easy thing. We have just learned it. Latent heat of vaporization, you can define it by remembering the definition of the latent heat of fusion. So in the latent heat of fusion, we had taken the amount of heat energy required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point. Similarly, the latent heat of vaporization would be the amount of heat required to change 1 kilogram of liquid into gaseous at its boiling point at the atmospheric pressure. That will be the latent heat of vaporization. You have to remember the standard of 1 kilogram, and since vaporization is the process of changing liquid to gas, so the transitioning phase should be liquid to gas while writing the definition. Sublimation and deposition. Now we have learned about fusion, that is solid changing into liquid, and vice versa, and we have also learned about liquid changing into gas by vaporization, and vice versa, condensation we'll be learning. Now but a very interesting phenomenon, that is the change of the solid state into the gaseous state without reaching the liquid state. This phenomenon is seen in a few substances. Let's find out. A change of state directly from solid to gas without changing in the liquid state is called sublimation, and the direct change of gas to solid without changing into liquid is called deposition. In this diagram, you are seeing that a flask is taken, it is inverted, a funnel is taken, it is inverted in a china dish, and in that inverted funnel we have ammonium chloride. Okay, so we have plugged the top hole of the inverted funnel through cotton, and we are applying heat to this whole setup. In the china dish there is ammonium chloride. On supplying heat, you will observe that no liquid is forming, rather at a certain temperature all the solid ammonium chloride, it is forming vapors. Okay, it is forming ammonium chloride vapors. Now this particular area where heat is being supplied, this particular area, now since heat is supplied at the bottom, so the bottom part of this china dish, or the bottom part of this inverted funnel, that will receive more heat, that will be more heated as compared to the upper part of the inverted funnel, right? Because you are supplying heat from the bottom, so the same amount of heat to reach the upper part of the funnel, it will take more time. So what is happening? You will see dense fumes of ammonium chloride vapors collecting towards the bottom part where you're applying the heat. But when you move towards the upper stem of the inverted funnel, you will observe that there are solid ammonium chloride there. Why? Because towards the upper part of the funnel, the temperature is not that high where the solid ammonium chloride is transforming into its vapor. That is why there is a certain solidification happening at the upper part of the funnel where you are getting solid ammonium chloride. So this is the deposition process, and the changing of solid into vapors is the sublimation process. What is the effect of change of pressure on gases? When we start putting pressure and compress a gas enclosed in a cylinder, the gas starts liquefying. Applying pressure and reducing temperature can liquefy gases because the distance between the constituent particles decreases. Now what is happening, that you know that you can easily compress a large amount of gas into a small container, right? But you also will notice that when you are trying to compress and you're trying to fit in a large amount of gas, say in a container, but what will happen is when you keep increasing the pressure, okay, when you keep increasing the pressure, when you keep reducing the temperature. Why reducing the temperature? Because you know that when temperature is applied in a large quantity, when heat is applied in large quantity, the particles of matter, they move around more randomly because they get that more kinetic energy. But when you lower the temperature, the kinetic energy is reduced, it gets decreased. That is why when you apply a lot of pressure to gas and when you put them at comparatively reducing temperature, gases can be liquefied. And gases can be liquefied, and the LPG cylinder that you have in your home, if you go to your kitchen and you see the cylinder that you have, that is basically in that LPG there is the liquefied petroleum gas, okay, liquefied petroleum gas. So this liquefied petroleum gas is used in cooking. So basically what is happening is that the gas is coming to your home in a very solid shape, right, in a container where it is easy to carry, it is handy to carry, right? But inside that container there is that liquid gas. So but when you switch on the knob, so what is happening when you're switching on the knob? You are basically reducing the pressure. You're reducing the pressure that gas was there in that cylinder. When you're reducing the pressure and we are increasing the temperature, so that liquid gets transformed into the gaseous state, and that is how when you apply matchstick or when you lighter to the your kitchen your kitchen slate, and that is how the liquid LPG gets transformed into gas. Why is solid carbon dioxide known as dry ice? Solid carbon dioxide is stored under high pressure. It gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. That's why solid carbon dioxide is also known as dry ice. What is happening here? Basically that carbon dioxide, again, it's gas. So to change the state of gas into a liquid, you need a large amount of pressure. But again, to change the state of a liquid, to change the state of a gaseous state into a solid state, you need enormous high pressure. So solid carbon dioxide is stored under that enormous high pressure, and it gets converted directly to the gaseous state on decreasing of pressure to 1 atmosphere. What is happening is that when you decrease the pressure to 1 atmosphere, so that solid carbon dioxide, it will transition directly into the gaseous state. It will directly transition into the gaseous state without getting transformed into liquid. So because this is happening, because solid carbon dioxide directly transforms into the gaseous state, solid carbon dioxide is also known as dry ice. Conversion of temperature from Celsius scale to Kelvin scale. Temperature in Kelvin can get by adding 273 to the temperature in the Celsius scale. So 100 degrees Celsius, if you add 273 to 100, you will be getting 373 Kelvin. That is 100 degrees Celsius is equivalent to 373 Kelvin. There is a question. Convert the following temperature to Celsius scale. So you know that to convert Kelvin scale to the Celsius scale. Now there is an important thing to remember here as well. In the Celsius scale, you add degree, but in the Kelvin scale, there is no degree. Okay, so there is degree Celsius, but there is only Kelvin. So to convert a particular number from Kelvin to degree Celsius, you are going to subtract 273, but to convert a degree Celsius to Kelvin, you'll be going to add 273, like we had seen it here. So to convert 300 Kelvin into the Celsius scale, you will be basically subtracting 273 from this, and you will be getting 27 degree Celsius. So 300 degree Kelvin is equivalent to 27 degree Celsius. And to convert 573 Kelvin into Celsius scale, you will be subtracting 273 from 573, and that will be 300 degree Celsius. So 573 Kelvin is equivalent to 300 degrees Celsius. Second question, what is the physical state of water at 250 degrees Celsius and at 100 degrees Celsius? So you know that the boiling point of water is 100 degrees Celsius, okay? So it means that above 100 degrees Celsius, all the liquid state of water has transitioned to the gaseous state. So definitely at 250 degrees Celsius, all the water must have transitioned to the water vapor. So the physical state of water will be gas. But what about 100 degrees Celsius? 100 degrees Celsius is the exact temperature at which all the liquid water transitions into the gaseous state. But you may know that vaporization is a surface phenomenon, as I had explained you earlier, because although it is happening in bulk, but the surface particles, they will be transitioning first. So not all of the liquid, they are not at once transformed into a gaseous state at 100 degrees Celsius, because the temperature is fixed at 100 degrees Celsius, and the liquid particles, they are consuming all those latent heat. They are consuming all those latent heat to break the intermolecular force of attraction so that gaseous state can be achieved. So while this process is happening, all the particles of liquid cannot be said that they at once transform into gaseous state. So the physical state of water at 100 degrees Celsius would be gas, definitely, but it will also be liquid. Not all particles will transition at once to the gaseous state because of that latent heat factor that we had read about earlier. Question 3. For any substance, why does the temperature remain constant during the change of state? Now this is again owing to the latent heat, because the latent heat is in latent heat, what happens is that if you remember, the solid particles or the liquid particles, they are consuming that heat in order to increase their kinetic energy so that their intermolecular force of attraction is increased, okay, and intermolecular force of attraction is decreased and intermolecular space is increased, and they can transition. Question 4. Suggest a method to liquefy atmospheric gases. To liquefy atmospheric gases, you will be applying high pressure, okay, and you will be decreasing the temperature. Why? Because gases have high compressibility. So under a high pressure and when the temperature is low. So when the temperature is low, the kinetic energy will be low, and because of the kinetic energy will be low, so the gases cannot randomly circulate here and there. So to reduce their kinetic energy, to bring them closer to each other, atmospheric gases can be liquefied by reducing the temperature and by increasing the pressure.